Okay, so we are about to end this weird and crazy and wonderful journey that is the 1998 AP Calculus AB exam. We are going to do number 6 on the free response questions, section 2. That is the last problem of the test. And sweet, we get to use a graphing calculator. All right, let's do this. Before I get going, like the video and follow me so when I do another examination and put those videos up, you get those notifications and I get the recognitions because you like me. And all of this work is not for nothing. But you know what? Even if you don't like the video, it's not for nothing. I still helped you out. And that's what matters. Okay, let's get going. Question 6 states, consider the curve defined by 2y cubed plus 6x squared y minus 12x squared plus 6y equals 1. My God, we're going to have to do some work for this problem. Yeah, we're going to have to do some implicit differentiation. We'll get there in a moment. But the previous 5 problems weren't really that lengthy. I mean, one section might have been. I know I do a lot of explaining as I do this, so it takes more time than it should if you were just doing this test yourself, or if I was. This is going to be, how do I put this? Patience. Be patient as you go through this. It might be a lot of writing compared to the other problems, but be patient, take your time, and just slowly go through this, and let's get it done. Okay, so let's start with 6A. 6A is asking us, we'll start with green because that's not a very intimidating color. It's very pleasant. It's actually my favorite color. 6A says, state that the derivative, dy dx, of the equation above is 4x minus 2xy all over x squared plus y squared plus 1. Then we're going to have to come up with some equations of lines and etc. The great part is they give us the derivative for A. We just got to show it. Okay? So when it comes to B, the equation of the line, we already have the derivative. We can figure that out. That tells me that, okay, some people might make some mistakes in part A if it wasn't given to them. And part B would be wrong if part A wasn't given to them, if that makes sense. Either way, let's do this because you know what? We're going to nail this anyways. All right, so I've got to take the derivative of this equation implicitly, meaning it's like a related rates. Anytime I take the derivative of y, I need to write dy dx next to it, okay? X, not so much. But anytime I take the derivative of y, it's the same thing as taking the derivative of x, except I put dy dx next to it. So the derivative of 2y cubed is 6y squared. Dy dx. Okay. This next term is a product rule. Okay? Oh, highlighters. First term is 6x squared. Second term is just a y. So it is the first, 6x squared, times the derivative of the second, which is just y. So the derivative of y is dy dx, okay, plus the second, which is y, times the derivative of the first, which is 12x. That was that whole second term. Okay, let's go to the next one. We will go, how about this, this way. Okay, the derivative of a minus 12x squared is minus 24x. And the derivative of the last term, we'll do an orange. 6y is just 6. Okay, and oh, by the way, the derivative of any constant is 0. I don't know why my students always forget to take the derivative of that last term, of both sides, okay? Right, now the whole point here is I want to keep, oh, I get to use the highlighters twice? No way. I want to keep any term that has dy dx next to it, and I want to keep those on the left side and get rid of everything else, get everything else to the right side. All right? Yeah? Yeah, we good? Okay, so let's go ahead and start that. Go back here, and we'll go to the gray. All right, so I'm gonna rewrite that. That's 12xy. Okay, so what I'm going to do is as follows. All right, I'm gonna subtract 12xy, subtract 12xy. I'm going to add 24x plus 24x. Really, you know, I could have reduced all these numbers. I could have divided a 6 out of everything first. We'll do it afterward. And let's subtract 6. All right, so, oh, wait. You might have caught something. The derivative of 6y is a 6. I forgot to write dy dx next to it, which means I want to keep that on this side. I don't want to get rid of it. Ooh, good thing I caught that. Okay, good thing I caught that. That would be a shame to get so far and then realize I made a mistake all the way back here. So let me rewrite that whole thing now. I've got 6y squared dy dx plus, okay, this comes down, 6x squared dy dx. Then I have this still on the left side, okay, plus 6 dy dx equals, okay, left side bye-bye, left side bye-bye, negative 12xy, that's this, plus 24x. All right, at this point, if I wanted to, I'm going to divide 6 out of everything. Let's work with smaller numbers, shall we? We'll divide everything by 6. This cancels with everything. That's nice. So now, when I really dislike rewriting, but what did I say initially? Let's be patient. Let's write everything we can. So we got y squared dy dx, okay, plus x squared dy dx. Okay, plus, that's just 1 dy dx equals, okay, 6 goes into 12 twice, so it's minus 2xy, plus, and 6 goes into 24 times 4x. Here we go. Oh, man. We're doing good. Okay, take a break, take a breather if you need to. Take a shot of water. And let's factor out on the left side. Let's factor out our dy dx. Okay, I'm going to take this out of everything here. Meaning I have y squared plus x squared plus 1 equals. The right side stays the same. One step left, and this is just part A. Whew, thank goodness. Is I'm going to divide both sides by y squared plus x squared plus 1. What I do to one side, y squared plus x squared plus 1. This is what dy dx equals, okay? This is what we have here. Let's make sure that's exactly what they told us it should be. Okay, they have their positive 4x first, then their negative 2xy, which is what we have in the top here. Okay, all over x squared plus y squared plus 1. And again, they just happen to have the x squared first. That's legit. That is good to go. All right? Whew, that's nice. Wow, that was just part A. Part B tells us, let me box all this off. Part B says, write an equation of each horizontal tangent line to the curve. Now, I don't know about you, but I know that in order for a tangent line to be horizontal, that means the slope or the derivative equals 0. Okay, so let's first identify where that happens. Okay. All right. So, in order for my derivative to be 0, the numerator has to be 0. So I will say negative 2xy plus 4x equals 0. Okay, well, let's factor and solve a little bit, shall we? I can take out a 2 and an x, okay, and that would leave me with negative y plus 2 equals 0. And if I set each one of those equal to 0, okay, this is my second one, b. Say 2x equals 0. That happens when x is actually 0. And then negative y plus 2 equals 0. That means y has to equal 2 here. That happens at y equals 2. Okay? There you go. Those are the 2 points. But in order to write the equation of a line, okay, I need the slope and I need a coordinate. Because remember, the equation of a line, we're always going back to this. Y minus y1 equals m times x minus x1. So now there's 2 points. This isn't a coordinate 0, x, y, 2. It's 2 different places that this can happen, that we can have a horizontal tangent line. So that means when x is 0, I need to find the y. And here, we don't have the x, but we know when y is 2. I mean, maybe it happens to be the same thing. But no, it could be 2 separate points. So the million-dollar question is, okay, how do we get the original coordinate if we have one of the 2 values, x and y? We always go back to the original equation. That means I got to use, keep on scrolling up, this bad boy here. Okay, 2y cubed plus 6x squared y minus 12x squared plus 6y is 1. Let's do it for this one first, where x is 0. Let's figure out the y. So I'm going to rewrite this. I want to find f of 0. Okay, so I've got 2y cubed, because I'm solving for y, okay, plus 6 times x squared times y. Okay, again, I'm putting a 0 in for all the x's here. Okay, minus 12 times 0 squared, because this was an x as well, and plus 6y equals 1. All right? So I'm going right here. Okay, let's start doing anything times 0, bye-bye. Bye-bye. So I've got 2y cubed plus 6y equals 1. All right, guess what? I have a calculator. I'm going to graph both of this. I'm going to put into y1 this. Of course, I'll use my x's. And into y2, I'm going to put 1. I'm going to see where they intersect. Okay, maybe it intersects maybe up to 3 places. Let's see. And let's view the detached LCD. So I've got 2x cubed plus 6x. Instead of equal, I want to see where it equals 1. So let's graph this bad boy. And if we have a cubic, it should go up and kind of down forever. Oh, my Lord. That's a little fancy bend. Yeah, it looks like it only intersects at 1 point. If I wanted to zoom out, just to be sure I'm not missing anything outside a 10 by 10 window, that's a very, very, very far zoom out. And it just goes up and it doesn't come back down. And that's where we have our y equals 1. So I'm going to hit second, trace, intersect. Hit enter 3 times. 1, 2, 3. So there we go. Bottom left here, 0.165. Okay, 0.165. So this happens when y is approximately 0.165. So one of the coordinates that has a horizontal tangent line, okay, is 0, comma, 0.165. Now guess what? I got to do the same thing, but this time I'm going to put a 2 in for y. Oh my goodness. All right? Yeah, a lot of writing, like I said. Going to use the same thing, except I don't have an x. I have the y as 2. So I've got 2. Y is 2. That's 2 cubed. Plus 6x squared y, which is 2. Minus 12x squared. Okay? Plus 6 times y, which is 2. Where does that equal 1? All right? Well, here we go. This is 8 times 2. That's 16. Plus 12x squared minus 12x squared plus 12 equals 1. Okay, interesting thing right here. Okay, interesting thing. Positive 12x squared and negative 12x squared cancel. 16 and 12 give me 28 equals 1. That doesn't equal. That means there is no solution. There is no point here. I will never get an x value with a y value of 2 or have a horizontal tangent line. So good thing for us, that only happens once at this coordinate right here. Oh, man. Holy smokes. All right. All right, here we go. Here we go. Extendo. We're still not done. This is only part B. So it's y minus y1 equals slope times x minus x1. All right? Y minus 0.165, because that's my y value. Okay, I don't know my slope yet. X minus 0. Okay, that's nice. How do I find my slope? Well, my slope is my derivative. Remember, that was, what did I have here? Where is it? Negative 2xy. They give it to us. That's a lot of work. They give it to us right here. Okay, so if you were to mess up part A, you can at least do part B. But we came up with it right here. Okay, I'm going to throw a 0 in for all those x's and a 0.165 for the y's. Okay, so I have negative 2. I should probably go purple. Yellow's tough to see. Negative 2 times my x, which is 0, times my y, which is 0.165, minus 4 times my x, which is 0, all over 0.165 squared plus 0 for my x squared plus 1. Okay, the top is going to be 0. The bottom is not going to be 0. The bottom is going to be some number. I'm not going to calculate it out now. I mean, you can if you want. No, I mean, if you do it, it's 1 plus 0.165 squared. Okay, that's going to end up being 0. So my slope is 0 as well. I mean, did I really have to do this? Didn't they want to know the equation of a line where the slope was a horizontal tangent line? I didn't even have to do that. Okay? So, let's just clean this up. Okay, so we got y minus 0.165 equals 0, because anything times 0 is 0. Add 0.165. Y equals 0.165. It should be a horizontal line where y equals a number, because they want the equation of a horizontal tangent line. There it is. Wow. It's a lot of work, and we are only through A and B. We still need to do C. Okay, we still need to do C. Let's box that off now. Let's call that a day right there. That is some work. What did I say before we started this? We're going to have to do some writing. Be patient and get through it, okay? If you need to pause and rewind some of this to go back, that is fine. Go ahead and do that. We are on part C, okay? We are on part C. All right. And part C starts out easy. And, you know, it's Still some work to do. I don't know what's happening there. Let's just go down here to calligraphy, and let's pick a refreshing, this light minty green. Let's go all the way up. C. The line through the origin with a slope of -1. That's our m value of slope. If it's through the origin, that means it's the coordinate 0, 0, okay? And my slope is -1. Is tangent to the curve at point P. Find the x and y coordinates of point P. Okay, so if I'm going to find a coordinate, I'm eventually going to have to go into here, my original equation, to find coordinates. But for right now, let's start with what they gave us. Holy poopsicle. Part C. The equation, the tangent, okay, so I got to find the line that goes through that point. Let's first find the equation of a line, right? Y minus y1 equals m times x minus x1. All right, it was through the origin, which means my y is 0 and my x is 0. Okay? And it had a slope of -1. Okay, so y equals -x. Okay, this is going to come in handy. All right, so now I need to find the actual point on my graph where y is going to equal -x. Guess what I need to use? I have my 2y cubed plus 6x squared y minus 12x squared plus 6y equals 1. Any place there's a y, I'm going to substitute now. Any place there's a y, I'm going to replace it with a -x. Ba-boom right here, ba-boom right here, ba-boom right there. So let's go ahead and rewrite that. Okay, and now we'll go with the regular green. So 2 times -x cubed plus 6x squared times -x minus 12x squared plus 6 times -x equals 1. Again, every y is a -x. How do we get that? Right here. All right, so I've got -2x cubed, all right, -6x cubed, okay, minus 12x squared minus 6x equals 1. It's a lot of negatives. These two can combine. -8x cubed minus 12x squared minus 6x equals 1. I don't know how to do that. Well, I mean, I do. But I'm just going to put this in my calculator. Again, I'm going to put this in my calculator. All right? I'm going to graph in y1 and y2. And I am going to, hopefully, let's erase this, get an answer. Well, let's go to y equals. Clear this out. We got -8x cubed minus, was it 12x squared minus 6x. Let's make sure that was it. Yes, it was. And I want to set that equal to 1. So my next equation is already at 1. Zoom, let's go to a standard. I'm just going zoom 6, so it goes back to a 10 by 10 window. And I want to see where these intersect. Okay, there you go. Boom. Okay, right here. I got to find that point of intersection. Okay, so again, I'm going to go second, trace, pick intersect, which is 5. Hit enter 3 times. 1, 2, 3. Oh, -0.49999. I'm going to call that -1/2. Okay, so that happens at approximately when x is -1/2. I have my x value. How do I get my y? Oh, I got to put it back into the equation. So for every x, it's going to be -1/2. I told you this was a lot of work. This is if you can get through this, that's remarkable. So I've got 2y cubed plus 6, now my x is negative 1/2, squared y, okay, minus 12 times negative 1/2 squared, plus 6y equals 1. I tell you what, I'm going to put that in the calculator just like that, okay? In the calculator, I'm going to make my y's, x's in the calculator, but I'm going to type in the negative 1/2 in the parentheses just like that instead of equal to 1. All right? So let's go. Let me scroll this down so I can see it right down there at the bottom of the board here. Move this over here. There's a method to this madness. Scroll up. So let's go to y equals. Clear this out. I'm going to put 2x cubed. Pop out of there. Plus 6 times negative 1/2 squared times my variable, which we're going to use x, minus 12 times negative 0.5 squared plus 6 times my variable x, whoo, equals 1. Let's graph that, and let's see where those intersect. This is, woo, rigorous. This is rigorous. Okay, I don't see it intersect anywhere. But you know what? This is cubic. It shouldn't both go up forever. So I'm going to zoom out. Pick choice 3. It should come back down at some point. Let's see where this comes back down. Where is it? I still don't see it. Let's keep going. I'm going to do zoom, and I'm going to go to fit. So it fits all the important stuff that I want in my calculator to fit. Okay. Okay, see, down forever, up, holy cow. Okay, let's do this. Right at this point, second, trace, intersect. I'm hoping it intersects at some point. Enter 3 times. It's thinking. It's thinking. Quit. Oh, no. Let's make sure I did this correct. Okay, let's make sure I did this correctly. Boom. Let's go here, go to y equals. It is 2. What is the 6 right here? What is the 6 right here? Delete. What is happening? 2x cubed. Oh, that was supposed to be, there's supposed to be a plus there. Second, insert the plus, plus, now a 6. Oh my goodness. Was that it? I just didn't have the plus sign in there? Let's see what happens now. It's spinning. Okay, it looks like now, let's go back to standard. And I apologize. Zoom 6 for my standard window. Let's see what happens. Okay, bam. Oh, now it definitely crosses. It definitely crosses. Oh, man. All because I didn't have the plus sign in there. Second, trace, intersect, enter, enter, enter. That is -6. No, we made another boo-boo. I don't think that's the answer. All right. 2x cubed plus 6 times -1/2 squared x minus 12 times -1/2 squared. Oh my goodness gracious. Second insert squared plus 6x. 1. Graph it one more time. Okay. Okay. There we go, kids. There we go. Well, I can't promise anything until I get an answer. All right, now let's try and do this. Second, trace, intersect 5. 1, 2, 3. There it is, 0.5. Holy smokes. There it is. Oh, so this, in the calculator, would be y is 1/2. So at what point does that tangent line go through? Negative 1/2, 1/2. Man, I feel like I just went 12 rounds of Tyson. Right there, Mike Tyson. Let that be a testament to entering things in the calculator correctly. Now, when I did this before. I shot the video, and I had a handheld calculator, and I was doing it in there. It isn't an excuse, but sometimes when I do it on the board, and I think I hit numbers, I don't. The numbers don't come up on the board on the digital calculator. But there it is. Man, that was a lot of work. That was a lot of work. But you know what? If you make mistakes, that's fine, as long as you can go back and catch them. Because if you do your work without making mistakes, God bless you, man. That's awesome. But if you make a mistake, it's a higher sign of intelligence if you can figure out where you make it. I know you think I'm just saying that because I made a mistake typing the numbers in the calculator, but if I wouldn't have been able to find it, it would have driven me crazy. And 9 times out of 10, when you're using a calculator with something complicated, you've mispunched something into the calculator, which I did there on 2 occasions. So, but we found it and we're good to go. Man, you might want to pause, rewind, see all that again. That's crazy. That's a lot of work. Exams nowadays aren't nearly this involved to solve problems. That's nuts. Because keep in mind, 1998, 24 years ago. Hey, if after all that you don't like this video, okay, you don't ring that bell, you don't follow me, man, what's wrong with you? That's crazy. That's a lot of work I just did. Hopefully I helped you. Hopefully I showed you that everybody's human. And when you make your mistake, that's fine. But you got to learn from your mistakes. You have to figure them out. That's where growth comes from. And you know what? We're done with this exam, thank God. Ring the bell. Follow me because I will put up more stuff. And you know what? I'm going to solve a Rubik's Cube soon. I'm going to solve a Rubik's Cube soon. Give you directions because there's something so fascinating about it, and all my students gravitate to it. So I'm going to show you guys what that's all about. All right. Have a good day.